Hey guys, it's Mr. T again, another video, this one on the gradient and y-intercept of a line. This should help you out with exercise 12b of your 11 General Maths textbook. So a straight line that's drawn on a Cartesian plane is just one of those grids with axes. So a straight line can be fully defined by its gradient, the slope of the line, and its y-intercept wherever it crosses the y-axis. So let's have a look at the gradient to start off with. You can always calculate the gradient of any line passing through 2 points, the first point being x1, y1, and the second point being x2, y2. So these are the coordinates of those points. You can find the gradient of any line passing those 2 points using this formula. The gradient is going to be the y value of the second point, take the y value of the first point, all divided by the x value of the second point minus the x value of the first point. You'll get an example of that later. The y-intercept is a bit simpler. You can find the y-intercept of a line just wherever it crosses the y-axis. So the y-intercept would be given as the y-coordinate, wherever it crosses the y-axis. Mathematically, and this will come into it later, the y-intercept is wherever the y value is when x is equal to 0. Because you'll notice when x is 0, the y-axis goes straight up and down through there, through wherever x equals 0. So let's go through an example to show you what the kind of questions are that you'll have to face and deal with and interpret. So this is the one from the book. I'm going to go through it with my thoughts animated here. Adam uses a hose to fill his horse's drinking trough. The volume of water in the trough is recorded every 2 minutes. The results of the recordings in the table below. So here's your table. You're recording every 2 minutes, 0 when he started, 2 minutes, 4 minutes, 6 minutes, 8 minutes, and you can see he started off with 30 litres in the trough already. After 2 minutes it was 50, after 4 minutes it was 70, 90 and 110. We can tell this is a linear relationship because it's going up by 2 in time, so that's going up a constant amount, and this is going up by 20 every time, so that's going up by a constant amount as well, so it's going to be a perfectly linear relationship. So of course, first question, draw a graph of the volume against time. So hopefully I got space for this. Haven't done this before, adding a grid, because my drawing skills are pretty bad already. Yep, here we've got a grid. I'll rotate that. Yep, it's not going to be perfectly straight up and straight down, but you can deal with that. So answering A, you guys need to remember from previous years the difference between a dependent and independent variable, because you always put the independent variable, the one that you're changing on purpose, on the bottom, on the x-axis, and then the dependent variable, the variable that changes because you're you're changing the independent one, that goes on the y-axis. So if you look at the question and work out what he's doing, he's filling up the thing over a period of time. So what he's changing is how long he's filled it for. So in maths, marks are assigned to your axes and whether you've put them in right. Okay, so the independent variable here is going to be time in minutes, because that's what he's changing on purpose, how long he's filling it for. And what changes depending on how long he's been filling it for? The volume, V in litres. Okay, so now we've set up the x and the y axes. We need to check how many units do we need to go from. So 0 to 20. 0, 2, 4, 6, 8, so we can go up in ones. We can start off at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm using 2 boxes per number. Right, hopefully that's clear enough. My pencil is not super accurate. It's pretty accurate, not super accurate. So yeah, I won't finish it off. And the volume needs to go from 30 to 110. You're allowed to decide where your y-axis starts, but for our purposes, I'm going to start at 0 and decide on a scale that will go up to 110. So if I quickly look at this, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30. That's not going to be enough because I already know I need to work out 160. In your book, you would be able to extend it, so I'm going to have to go up 20 each time. 20, 40, 60, 80, 100, 120, 140. So that's going to be able to answer my question C. I need to think ahead because I can't redraw stuff easily here. 200. Alright, so I can draw the graph now using that table. At time 0, the volume is 30. So 30 is going to be here. At time 0. At time 2, the volume is going to be 50. So that's going to be between 40 and 60. That's going to be there. At time 4, it's going to be at 70. And it's going to be between 80 and 60. You can see it's forming a straight line already. At time 6, it's going to have a volume of 90, so that will be here. And at time 8, it's going to have a volume of 110, so that's going to be between 100 and 120, so that's going to be there. So you can see it's going to form a straight line. So now I need to draw a straight line through those points. I don't have one of those special Apple ruler things that you can get, so I'm going to try my best to draw a straight line with the line function here. It might not turn out well, we'll see how we go. So, that's useless. Try again. So, trying to draw a straight line across there. Hopefully that's going to fit along the points. Let's see how we go. Yeah, that's pretty good. So for some reason it places the line not where I've put the pen. So I sort of have to line it up afterwards. So that's not going to be perfect. We might have to mathematically find the intercepts. But it should be pretty close. So I've drawn a straight line through the points. So that is the graph drawn, that's A. B, find the gradient of the graph, explain what it means. Well, I've already told you the gradient is equal to the second y-coordinate, the y-coordinate of the second point, take the y-coordinate of the first point. So if we look, say, here and here, the y-coordinate there is 90 minus the y-coordinate of the left point, so this would be 0.2, this would be 0.1. The y-coordinate of the first one would be 30, and the x-coordinate would be 6 of the second point and 0 of the first point, so that's going to be 90, take 30 is 60, over 6, that's going to be 10. So a gradient of 10. Explain what that means. Therefore, for every 1 unit of x, which is time, in minutes, the volume goes up by 10 litres. Okay? Because really, the gradient is 10 over 1. So what that's telling you is for every 1x, it goes up 10y. So that's B. For C, find the y-intercept of the graph, explain what it means. Well, you can see the y-intercept here. Alright, you can see that the y-intercept is 30, or if you wanted to work it out, it's wherever x is equal to 0. X is equal to 0 here, so what is it, y? It's at 30 as well. Y-int is equal to 30, so volume of 30 litres at time 0. What does that mean? It means the trough starts at 30 litres. D. What volume is the trough at 6 minutes? Well, hopefully we've drawn the line straight enough that it goes through the point, and you can see our point 2 is the time at 6 minutes. So the volume of that is going to be here, which is between 80 and 100. So it's going to be 90 litres. So at 6 minutes, volume is 90 litres. Alright. And then E, how long would it take for the volume to reach 160 litres? Well, this one is the one that depends on the line being drawn straight. This is 160 litres. We don't have a point. We don't have a point on our chart that is a volume of 160, so we don't have an exact value. We have to go either on the graph or go on the relationship here. So we could work out by extending the graph, extending the chart. So this is going up by 20 each time. So plus 20, that's going to be 130, plus 20, 150, plus 20, 170. So 160 is going to be halfway between those two. 160 is going to be here. Alright, and so this is going up by 2 each time. So plus 2 is going to be 10, plus 2 is going to be 12, plus 2 is going to be 14. So halfway between 12 and 14 is going to be 13. So based on this relationship in the chart of our data, it should be at 13 minutes. Let's check if our line is straight and tells us the same thing. 160, go across. I can't draw very accurately on this line, on this screen, but yeah, there we go. It pretty much crosses the point at 13 minutes. So E, answering the last question, how long would it take for the volume to reach 160 litres? It would take 13 minutes to reach 160 litres. Alright, so that is an example of answering questions using a graph, okay, using the gradient and intercept of the lines and explaining what they mean. Hopefully that helps you out, and I'll see you on the next video.